Hello. Welcome to the Quiet Observatory. My name is Atta. Tonight, we're going to look at something familiar from an unfamiliar perspective. We're going to look at home. Not your house, or your city, or even your country. Home in the largest sense. Earth. The planet that holds everything you've ever known, everyone you've ever met, every place you've ever been. We're going to view it from space, from distances so great that continents vanish, that oceans become indistinguishable from land, that Earth itself becomes nothing more than a single pixel of light suspended in darkness. There's a photograph taken in 1990 by the Voyager 1 spacecraft from the edge of the solar system, nearly 6 billion kilometers from Earth. In that image, Earth appears as a tiny dot, barely visible, less than a pixel wide, a pale blue speck caught in a beam of scattered sunlight. When Carl Sagan saw this image, he reflected on what it meant. He wrote, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a mote of dust suspended in a sunbeam." Tonight, we're going to journey outward, step by step, looking back at Earth from increasing distances. We'll watch our planet shrink from a world to a marble, to a point of light, to something invisible entirely. And in that journey, we might find perspective, a shift in how we see ourselves, our conflicts, our place in the vastness of space. Let's begin close to home, just a few hundred kilometers up, where astronauts orbit the Earth and look down at the world they left behind. The International Space Station orbits Earth at an altitude of about 400 kilometers, roughly the distance from New York to Boston. From that height, astronauts have a view that's been described as life-changing, perspective-altering, even spiritual. It's called the overview effect. The term was coined by Frank White, who interviewed dozens of astronauts and cosmonauts about their experiences viewing Earth from space. What he found was striking. Nearly all of them reported a profound shift in perspective, a sense of awe and connection that stayed with them long after they returned to Earth. From the ISS, Earth fills most of the sky. You can see the curve of the horizon, the thin blue line of the atmosphere, and below that, the details of the planet's surface, continents, mountain ranges, rivers, coastlines, weather systems. But what you don't see are the things that dominate maps and human consciousness on the ground. Borders, political boundaries, the lines we've drawn to separate one nation from another, lines we've fought wars over, lines that seem so important from the surface. From space, they're invisible. You see the Sahara Desert, vast and golden, stretching across North Africa, but you don't see where Algeria ends and Libya begins. You see the Korean Peninsula, a single landmass, not divided into north and south. You see Europe as a continuous whole, not fractured into dozens of countries. The borders exist only in our minds, in our agreements and disagreements. They're human constructs, entirely artificial, and from space, they vanish. What remains is a single interconnected world, oceans flowing into each other, atmosphere circulating as one, ecosystems spanning continents. Astronauts often describe being struck by how thin the atmosphere appears. From the ground, the sky seems vast, infinite. But from orbit, you can see that the breathable atmosphere, the troposphere, where weather happens and planes fly, is just a thin shell, perhaps 10 to 15 kilometers thick. If Earth were an apple, the atmosphere would be thinner than the peel. It's a delicate, fragile layer. There's no backup, no spare atmosphere. Everything that keeps us alive, the oxygen we breathe, the ozone that shields us from ultraviolet radiation, the greenhouse gases that keep the planet warm enough for liquid water, exists in that impossibly thin shell. And it's beautiful. Photographs don't quite capture it. The atmosphere appears as a blue gradient, deep blue at the surface, fading through lighter blues to the black of space. At sunrise and sunset, when the sun illuminates the atmosphere edge on, the colors shift. Blues, oranges, reds, purples. A glowing arc on the limb of the planet. The Russian cosmonaut, Yuri Gagarin, the first human in space, radioed back after reaching orbit. The Earth is blue. How wonderful. It is amazing. He was the first to see it with human eyes. On April 12, 1961, he orbited Earth once, a flight lasting just 108 minutes, and became the first person to gain this perspective. Astronauts aboard the ISS orbit Earth 16 times a day. Every 90 minutes, they complete one circuit. Every 45 minutes, they see a sunrise or sunset. They watch thunderstorms from above, lightning flashing beneath them like camera flashes. They see auroras, green curtains of light wrapping around the poles. They watch hurricanes, massive spiral systems, hundreds of kilometers across, churning across the oceans. And they see Earth as a whole, as a system, interconnected, dynamic, finite. Many astronauts report a shift in their sense of identity. They go up as Americans, Russians, Japanese, Europeans. They come back as Earthlings. The Canadian astronaut Chris Hadfield, who spent months aboard the ISS, described the experience this way. You can't help but look at Earth and think about the fact that we're all traveling together on this one spaceship, and there are no borders from space, no divisions. It's just one beautiful, fragile planet. The American astronaut Ron Garan said, "When I looked out the window of the International Space Station, I saw the paparazzi-like flashes of lightning storms. I saw dancing curtains of auroras, that seemed so close it was as if we could reach out and touch them. And I saw the unbelievable thinness of our planet's atmosphere. In that moment, I was hit with the sobering realization that that paper-thin layer keeps every living thing on our planet alive. I saw an iridescent biosphere teeming with life. I didn't see the economy. But since our human-made systems treat everything, including the very life support systems of our planet, as the wholly owned subsidiary of the global economy, it's obvious, from the vantage point of space, that we're living a lie. This is the power of perspective. From orbit, the things we think are important, stock markets, political disputes, national pride, shrink in significance. What becomes obvious is our shared vulnerability, our dependence on this one planet, our interconnection. The view from the ISS is still relatively close to Earth, close enough to see details, close enough to feel connected to the surface below. But let's go farther. Let's travel to the moon and look back from there. On December 24th, 1968, 3 astronauts, Frank Borman, Jim Lovell, and Bill Anders, became the first humans to orbit another world. They circled the moon 10 times, preparing for the Apollo landing missions that would follow. They had come to explore the moon, to map landing sites, to prove it could be done. But what they discovered was Earth. On the 4th orbit, as their spacecraft emerged from behind the moon, something unexpected appeared in the window. Earth, rising above the lunar horizon. Bill Anders, the mission photographer, scrambled for a camera loaded with color film. He captured the image. Earth, a brilliant blue and white marble, half in shadow, rising above the grey, lifeless expanse of the moon. This was Earthrise. The image is iconic now, one of the most reproduced photographs in history. But at the time, it was unprecedented. No one had ever seen Earth from this perspective, not as a world beneath them, but as a world beside them. A celestial object in its own right, floating in the blackness of space. The contrast was striking. The moon, grey and cratered, dead for billions of years, airless and silent. And Earth, vibrant with color. Blue oceans, white clouds, hints of brown and green where continents showed through. The moon is barren. Earth is alive. The astronauts were not particularly poetic men. They were military test pilots, engineers, pragmatic and focused. But even they were moved by what they saw. Frank Borman later said, "When you're finally up at the moon, looking back at Earth, all those differences and nationalistic traits are pretty well going to blend, and you're going to get a concept that maybe this really is one world, and why the hell can't we learn to live together like decent people?" Bill Anders, reflecting on the mission years later, said, "We came all this way to explore the moon, and the most important thing is that we discovered the Earth." The Earthrise photograph had a profound cultural impact. It's credited with helping to spark the modern environmental movement. The first Earth Day was held in 1970, just 2 years after the image was taken. People saw the photograph and understood, perhaps for the first time, that Earth was finite, fragile, isolated, a lone oasis in the vast darkness. There was nowhere else to go, no other planet to escape to if we ruined this one. We were, as the image made clear, living on a small, vulnerable world that needed to be cared for. From the moon, Earth is about the size of a marble held at arm's length. You can cover it with your thumb. All of human history, every city, every war, every triumph and tragedy, hidden behind your thumb. The moon is about 384,400 kilometers from Earth, roughly 30 Earth diameters away. It's the farthest humans have ever traveled from our home planet. 12 people have walked on the moon, and 24 have orbited it. All of them came back with a changed perspective. The moon and Earth form what's sometimes called a double planet system. The moon is unusually large relative to Earth, about 1/4 Earth's diameter, far larger than most moons relative to their planets. The only other similar system in the inner solar system is Pluto and Charon, and Pluto isn't even considered a planet anymore. The moon stabilizes Earth's rotation, keeping our axial tilt, the tilt of our rotation axis relative to our orbit, relatively constant at about 23.5 degrees. Without the moon, Earth's tilt would vary chaotically over millions of years, causing wild swings in climate. The seasons would become unpredictable. Complex life might never have evolved. We owe a great deal to the moon. Our stable climate, our tides, perhaps even life itself. And the moon gave us something else, a place to stand and look back, to see ourselves from outside, to gain perspective. But let's go farther. Let's leave the Earth-Moon system behind and venture into the inner solar system, where Earth becomes just one planet among many. From Mars, Earth appears as a bright star in the sky, a morning or evening star, depending on the alignment of the planets. You could see it with the naked eye, a brilliant blue-white point of light, brighter than anything except the sun. Mars rovers have photographed Earth from the surface of Mars. In those images, Earth is just a dot, sometimes accompanied by an even tinier dot, the moon, barely visible beside it. From Mars, which is on average about 225 million kilometers from Earth, you cannot see continents. You cannot see clouds. You cannot resolve any detail. Earth is simply a point of light, indistinguishable from a star, except that it doesn't twinkle. Planets shine steadily because they're close enough that their light doesn't get scattered by Earth's atmosphere in the way starlight does. But Mars rovers aren't on Earth, so for them, Earth does twinkle slightly, its light passing through Mars's thin atmosphere. In 2013, the Cassini spacecraft orbiting Saturn captured an image called "The Day the Earth Smiled." Saturn fills the frame, backlit by the sun, its rings glowing. And there, in between the rings is a tiny pale blue dot, Earth, barely a pixel across, 1.5 billion kilometers away. NASA announced the photo session in advance and encouraged people to go outside and wave at Saturn at the precise moment the image would be taken. Nearly 1 billion people participated, making it one of the most widely photographed moments in human history. Not because anyone would appear in the photo, but because of the shared experience, the collective acknowledgement of our place in space. These images, Earth from Mars, Earth from Saturn, put our planet in context. We are one world among many in our solar system, not the largest, not the smallest, not the closest to the sun or the farthest, but unique in one crucial way. We have liquid water on our surface, and we have life. Let's compare Earth to its neighbors. Venus, the second planet from the Sun, is almost Earth's twin in size, just slightly smaller, about 95% Earth's diameter. But Venus is a hellish world. Its atmosphere is 90 times denser than Earth's, made mostly of carbon dioxide, with clouds of sulfuric acid. The surface temperature is 465 degrees Celsius, hot enough to melt lead, hotter than Mercury, even though Mercury is closer to the Sun. This is because of a runaway greenhouse effect. Venus once may have had oceans, but as the Sun brightened over billions of years, the water evaporated, creating more water vapor in the atmosphere, which trapped more heat, which evaporated more water, and so on. Eventually, the oceans boiled away completely. The water vapor was broken apart by ultraviolet light, and the hydrogen escaped to space, leaving behind a thick, dry, superheated atmosphere. Venus is what Earth might become if we're not careful. A cautionary tale of what happens when greenhouse gases run amok. Mars, the fourth planet, is the other cautionary tale. Mars once had liquid water on its surface. We can see the evidence. Ancient riverbeds, lake basins, minerals that only form in the presence of water. Mars once had a thicker atmosphere, warmer temperatures, perhaps even oceans. But Mars is small, about half Earth's diameter, and its core cooled relatively quickly. The magnetic field generated by the core shut down billions of years ago. Without a magnetic field to protect it, the solar wind gradually stripped away Mars's atmosphere. The planet dried out, froze, and became the cold, barren desert we see today. Earth sits in the habitable zone, the range of distances from the Sun where liquid water can exist on a planet's surface. Not too close, like Venus. Not too far, like Mars. Just right. But it's not just distance. Earth has a magnetic field generated by its liquid iron core that shields us from the solar wind. Earth has plate tectonics, which recycles carbon dioxide between the atmosphere and the crust, regulating the climate over geological timescales. Earth has a large moon that stabilizes its axial tilt. All of these factors combine to make Earth habitable. Change any one of them, and Earth might be as lifeless as Venus or Mars. From the inner solar system, Earth is special, but not unique. It's one planet among 8, orbiting an ordinary star in an ordinary galaxy. But as far as we know, and we've searched extensively, it's the only planet in the solar system with life. And that makes it, for us at least, infinitely precious. Now let's go even farther. Let's leave the solar system behind entirely and see Earth from the perspective of interstellar space. On February 14th, 1990, Voyager 1, which had completed its mission to explore Jupiter and Saturn, turned its camera back toward the inner solar system one last time. At Carl Sagan's urging, NASA commanded the spacecraft to take a series of photographs, a portrait of the solar system from 6 billion kilometers away, beyond the orbit of Neptune, near the edge of the Sun's influence. In one of those images, Earth appeared as a pale blue dot, less than a pixel wide, suspended in a beam of scattered sunlight. This is the image that inspired Sagan's reflection, his meditation on the fragility and preciousness of our world. He wrote, "That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." From Voyager 1's perspective, 6 billion kilometers away, Earth is invisible without the aid of a spacecraft camera. The Sun is a bright star, and Earth is lost in the glare beside it, detectable only when you know exactly where to look. This is as far as any human-made object with functioning cameras has ever been. Voyager 1 has since traveled farther. It crossed the heliopause, the boundary where the solar wind meets interstellar space, in 2012. But its cameras were shut down long ago to conserve power. If you could travel to another star system, say Alpha Centauri, the closest star system to our own, 4.2 light years away, and look back at the Sun, you'd see it as a bright star among many. Earth would be completely invisible, lost in the Sun's glare, far too faint and too close to the Sun to be detected, even with powerful telescopes. This is one of the great challenges of finding planets around other stars. The planets are tiny, dim, and very close to their much brighter parent stars. It's like trying to see a firefly hovering next to a searchlight from hundreds of kilometers away. We've developed techniques to overcome this. We can detect the gravitational wobble a planet induces in its star as it orbits. We can measure the slight dimming when a planet transits in front of its star. We can even block out the star's light with a coronagraph and image the planet directly, though this only works for large planets orbiting far from their stars. Since the first confirmed exoplanet discovery in 1995, we found over 5,000 planets orbiting other stars. Some are gas giants like Jupiter. Some are rocky worlds like Earth. Some orbit in their star's habitable zone, where liquid water could exist on the surface. But we haven't yet found another Earth, a rocky planet the same size as ours, at the same distance from a sun-like star, with liquid water and an atmosphere. We're close. The James Webb Space Telescope and future missions may detect atmospheric biosignatures, oxygen, methane, combinations of gases that suggest life, on planets around nearby stars. But for now, as far as we know, Earth is unique. Out of thousands of known exoplanets, none are quite like ours. This doesn't mean we're alone. The Milky Way contains between 100 and 400 billion stars, and most of them have planets. If even a tiny fraction of those planets are habitable, and a tiny fraction of habitable planets develop life, and a tiny fraction of life-bearing planets develop intelligent life, there could still be thousands or even millions of civilizations in our galaxy alone. And there are at least 2 trillion galaxies in the observable universe, each with billions of stars. The numbers are staggering. The Fermi paradox asks, if intelligent life is common, where is everyone? Why haven't we detected signals, artifacts, evidence of other civilizations? Maybe life is rarer than we think. Maybe intelligent life is much rarer. Maybe civilizations destroy themselves before they can expand beyond their home planets. Maybe the distances are simply too great, and the universe is too vast for civilizations to ever make contact. We don't know. We're still searching, listening with radio telescopes, looking for technosignatures, sending our own signals into space. But so far, silence. The universe is vast beyond comprehension. The observable universe, the region from which light has had time to reach us since the Big Bang, extends about 46 billion light-years in every direction, giving it a diameter of 93 billion light-years. But the universe is expanding. Galaxies farther than about 15 billion light-years are receding from us faster than light, because space itself is expanding between us. We will never see them, no matter how long we wait. They are beyond our cosmic horizon, causally disconnected from us. And the universe beyond the observable universe may be infinite. We don't know. We can only see a finite patch. In this vast cosmos, with its trillions of galaxies, its septillions of stars, its uncountable planets, Earth is one small world, circling one ordinary star, in one spiral arm of one galaxy, among billions. From the perspective of the universe, we are cosmically insignificant. A rounding error. a speck of dust in an infinite ocean. And yet, here's the paradox. Earth is cosmically insignificant, but infinitely precious. Insignificant because the universe is vast, and we occupy only the tiniest fraction of it. We could vanish tomorrow, and the universe would continue, indifferent, unchanged. But precious because it's ours, because it's the only home we have, and likely the only home we'll ever have. Because everything we've ever known, everyone we've ever loved, every experience we've ever had happened here, on this one world. Carl Sagan understood this. After describing Earth as a pale blue dot, he continued, "Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand." It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the pale blue dot, the only home we've ever known. This is what perspective teaches us. Not nihilism, not despair at our insignificance, but responsibility, humility, appreciation. When you see Earth from space, from orbit, from the moon, from the edge of the solar system, the petty divisions that occupy so much of our attention on the ground seem absurd. The borders vanish. The conflicts shrink. What remains is a single, fragile world, beautiful and vulnerable, the only harbor we have in a vast and indifferent cosmos. There's no planet B, no backup Earth, no cavalry coming to save us if we destroy this one through war, pollution, or negligence. We're on our own, and that makes every square kilometer of Earth's surface, every living thing, every breath of clean air, every drop of fresh water, infinitely valuable. From space, you can see that we're all traveling together on this one spaceship. There are no passengers, only crew. We're all responsible for maintaining our vessel, for ensuring it continues to support life. The environmental challenges we face, climate change, biodiversity loss, pollution, deforestation, are not abstract problems. They're threats to our life support system, to the thin shell of atmosphere and the complex web of ecosystems that keep us alive. From space, these challenges are obvious. The atmosphere is visibly thin. The glaciers are visibly melting. The rainforests are visibly shrinking. The perspective makes it clear. Earth is finite. and we must care for it. But perspective also teaches us something hopeful, that despite our differences, we're fundamentally the same. We're all humans, all citizens of Earth, all dependent on the same planet. The astronauts who've seen Earth from space often return with a sense of unity, a recognition that the things that divide us are smaller than the things that unite us. We share one atmosphere. We share one ocean. We share one biosphere. We're connected by flows of air and water, by trade and communication, by history and culture. We're parts of a single system. And that system, for all its problems, is also beautiful. Earth is a rare jewel in the cosmos, a world with liquid water, with life, with minds that can look up and wonder about the stars. We're privileged to live here, in this brief moment of cosmic time, on this one world that, as far as we know, is the only place in the universe where matter has organized itself into beings capable of contemplating the universe. We are the universe's way of knowing itself. We're stardust that learned to think, atoms that learned to wonder. And that's extraordinary. For now, as you drift towards sleep, imagine a journey back. You've traveled far, out to the edge of the solar system, out to where Earth is a pale blue dot. You've seen your home planet from the perspective of the cosmos, tiny and fragile. Now imagine zooming back in, moving inward through the solar system, past Saturn with its glorious rings, past Jupiter with its turbulent storms, past Mars, past the asteroid belt. Earth grows larger. The moon swings into view beside it. You can see the curve of the planet now, the blue of the oceans, the white swirl of clouds. Closer still, you enter Earth's orbit. You can see continents, Africa, Asia, the Americas. You can see the thin blue line of the atmosphere, that delicate shell that holds everything you need to survive. You descend through the atmosphere. The sky brightens from black to deep blue. You pass through the clouds, and below you, the landscape appears. Mountains, rivers, forests, cities. You drift lower, slower. You see your country, your region, your city. The buildings and streets become visible. The trees, the parks, the places you know. And finally, you return to where you are now. Your room, your bed, solid ground beneath you, air around you, the gentle pull of gravity holding you safe to the surface of this world. Your home. On this small planet, this one world among billions, this pale blue dot, suspended in the vastness of space, carrying everything you've ever known. Earth is your home, not just your country or your city, but the whole planet. The forests and oceans, the deserts and glaciers, the atmosphere and the soil, the millions of species you share this world with. It's all connected. It's all one system, and you're part of it. Rest now, held by the gravity of this world, breathing the air of this atmosphere, warmed by the sun that shines on this one planet in this one solar system. You're safe here. You belong here. This is where you've always been, and this is where you are now. One small person on one small planet in one small corner of the universe. And that's enough. That's everything.